Hello, Narnach here. Welcome back to TIS-100. This episode we start on a new type of puzzle, one involving test images. So this is the image test pattern that we are going to have a look at. And it's an interesting one. So input-outputs are now different. Rather than a list of numbers, we are now working with images. So here we have a target image that we need to produce, and this is the current image as it stands. It's really completely blank. And at this point, if you are playing, you probably want to click this button here, hit escape, click this button, and it will open the PDF manual in your locally available PDF reader if you have one installed. And that's going to basically somewhere 3/4 into the book, I think there is a section on how images work, but I'm gonna explain it to you anyway. So in order to paint something on an image, you specify the x coordinate and the y coordinate. The top left is 0, 0, and then x just increases all the way up till 30. So 0 through 30 is what I have been able to determine. Or 0 through 29 it would technically be, because there are 30 items in the list. And down, because it's a square, it's also 30, and that's the y-axis, so that's also 0 through 29. So 0, 0, 29, 29. And you can paint this in the various colors that this game has available. And there are 5 colors available, to be precise. There is black, there is a darkish gray, a lightish gray, there's pure white, and there's red. So, in order to paint an image, you paint in lines. So you specify the x and y coordinate where you start, and from there on, you specify a list of color numbers that will be painted in sequence in a line. So, if you start all the way on the left side, the maximum length of that list can be 30 items until you hit the very end here. But you may also decide that you want to stop halfway through, for example. So you terminate the list of colors with a negative number, usually -1 is chosen, in order to mark that you are done painting. So this very first one is just a taste, so to say, for image painting. And all you have to do is paint the entire thing white. It was a fun enough exercise to do. So let's have a look at my very first attempt. So here you have the image output, and that means there's no input. So you can just basically have a single node that does all the work all the way next to the image output. But if you want, you can make it more complex and just funnel numbers around. It's your choice. So what do I do here? Well, we send out a sequence of x, y color numbers followed by a -1. So my idea is to just paint the entire line, then move to the next line, paint the entire line, move to the next line, and so forth until we reach the last line and we are done. So that's exactly what we do. So the first number that we need to send out is the x coordinate. So that's why I've conveniently labeled it with x. We send a 0 and we send it to the image. So that's going to be the first of the coordinate to indicate the x coordinate, and that's always going to be 0 because we always want to be all the way on the left side here. Then next up, I'm using the accumulator to store the y coordinate because it starts at 0, but we need to increment it by 1 every time we finish painting the line until we are at the very end. Okay, so we send it down, and then I swap it because I need to keep track of where I am painting with the numbers, or basically how many numbers I am painting. So I will need to use the other value in order to do that. So that's why I use the y coordinate, and then I swap it so it will be stored safely in the buck, and then I can do whatever I want in the uck to just iterate through the numbers. Okay, so we then get to the main loop that is just going to put 30 bits of color on the line here. So we send the number 3 and we send it out, which is going to be the color for white. After that, I subtract 28 from the number in the accumulator. So it starts at 0, then it becomes -28. And then if it's greater than 0, I break the line. So I found just through experimentation that this works, because now you need to be greater than 0. You already paint one out. So the moment after I don't do this, I add 29. So 28 off, 29 up. That means every combination of this, the number increases by 1. And at some point, the number is going to be greater than 0. So that means it's going to be 1. And then that means I've got exactly 30 numbers painted. And after that, I just jump back to color. And looking at this, there might be a way to inline it. No, actually not, because this is a greater than 0, and the reverse of that would be a double check. So this is as efficient as it gets. Otherwise, you need 2 instructions to check for equal to 0 and less than 0, which is not exactly what you want. Okay, so this will just iterate through, send out the number 3 all the time, and keep increasing the accumulator until it goes over 0, and then we end it. In which case we send a -1 to terminate the sequence of colors, and we send it out. And then we put the number 0 in the accumulator to clear it again, put it at 1, at 0. Then we swap the value, so the y-axis value goes back into ACK, and we add 1 to increase to the next line, and then we wrap around and we start all over again, but on the next line. And if you want to see this in action, you see that it slowly paints out. And yes, this is a pretty intensive way to paint. And if I go through it, it's 3377 instructions all the time. Okay, so then I started looking at ways to optimize this. So let's have another look at a slightly more optimized solution. So it turns out it actually is possible to inline the color thing, but I needed to change my condition checking slightly, because before I was checking if the jump was greater than 0. But the thing is, what I'm basically checking for is if it's 1 or not. So if I just change my numbers by 1, so to check if it's equal to 0, and then I just, rather than subtracting 28, I subtract 29 and I add 30 instead of 29. So in this case, the number 30 basically corresponds with the line number. Or 29 minus 1 is the number of lines, just depending on how you look at it. But because this is now a easier way to negate, I mean the opposite of a jump if equal to 0 is a jump if not 0. So there's a jump if equal to 0, and then a j and z. And that way I could inline the loop and remove one single roll jump out of it. And as a result, it gets a lot faster. And that saves about 500 cycles in return for just 2 extra instructions to make it this fast. Okay, so this is still the same strategy. And then I have a solution that's almost twice as fast as the optimized one and more than twice as fast as my initial solution. And it only uses 1 extra instruction. So for reference, this is the previous version. I've managed to actually improve version 1 even further by shaving off another 500 cycles. And let's see, what did I do here? I actually removed the inline version. It's just a single structure. This is just a more simple version. It's very, very, very tight loop this. And the main trick here is, rather than subtracting 28 and then adding a 30, I just subtract the 30 once before the loop, and then inside of the loop all I do is add 1. So this is more focused and less distracted than what I was doing before. And that's why it was another 500 cycles faster. And then notice how much space I've got here. I mean, I've got the 2 empty lines up here. I've got 2 empty lines down here. And all I do is send 1 number out and then add 1. But the thing is, I need to add 30 items. But I'm basically spending 3 cycles here to adding one color. So an entire line takes 90 cycles to paint in this way. If only there were a way to use less cycles per line. And that's exactly what I'm doing by painting 5 numbers in a row, like this. And then just adding the number 5 to indicate that it's 5. Because the thing is, you know, the line is 30 has a length of 30. So if the length is 30, and you need to end up exactly at 30 in the end in order for the boundary condition, in this case the negative 30 needs to be added up exactly to 0. So now if you do 30 times 1, that's exactly 30, so you end up on 0. But in this case, if I paint down 5 numbers in a row, and I do that 6 times, I'm also ending up at 30. But the nice thing is that I now have one loop here that paints 5, adds a number, and then does a jump. So that's 5 paints plus 2, that's 7 instructions for 5 numbers. So if I do that 6 times for 7 instructions, that's 42 instructions, rather than the 90 I was doing before in this already optimized loop. So this really cuts down on the number of instructions that you need to do. And I've already got all the labels in line. So unless I find a way to more efficiently deal with the overhead, there is no way to make it more optimal inside of this, inside of a single node. So that's why, as you notice, this goes a heck of a lot faster. And as a result, it will be 1487 instructions. So yeah, that was a very brief look at the image test pattern. It's a very simple image thing, but dealing with images itself is already pretty complex, and it took me a while to just wrap my head around of how it actually worked. And future puzzles are gonna get more interesting. I've already done the image test pattern, and it's also very fun. I'm gonna cover that one next episode. And after that, I can only imagine how more complicated and creative things are gonna get. And especially the last puzzles, I suspect they're gonna combine all the ingredients we've had before. So that will be stacks, that will be images, and all those fun things. So don't be deceived by how simple this one is. Things will get more complicated and will require more thinking. But it gives me something to do to explain it all to you, right? So thank you very much for watching, and hope to see you again next time. Bye bye.